In progress.
Have we all managed to get a complete layout? Now, in case I have, in AutoCAD, we have what we call zoomed extents. Yes. G1, J1. Now, that beam is supposed to be there. The curtain wall is constructed like a facade just after the beam. But then, remember, we have a slab there. What is going to receive that slab? That beam it must be there to act as a bound element, that slab. Yes. Okay, we can proceed. Most of the times you find that there are some tasks that you'll be required to do, most especially when you're navigating through the drawing environment. Like for example, zooming, panning. Okay. So if you want to zoom, we can get the zoom tool around here. We have zoom window. We have this other option, zoom extents. So in case I've maybe used my mouse wheel and I zoomed it to that with that factor, I can just click here, zoom extents, and then the whole drawing is positioned to the center of the drawing area. Then in case maybe you want to focus on a particular area, like maybe this connection, you can zoom window. Is this other option which has zoom window. Click on zoom window and then drag around the area of focus. Maybe it's this point, and it will take you to that position. So in case you do not have a mouse, you can make use of these two, zoom extents, zoom window, okay? But when you're working, you need to have a mouse. Now, when you look at your layout, you'll notice that there are some beams which have a red arrow pointing somewhere. Like for example, here, I have this arrow. This arrow is attached to all beams which are supposed to be designed as cantilever beams. Okay, so cantilever beams, those are beams with the support at one end. And this arrow will be always pointing to the direction of the support. But there are scenarios where you find that, for example, okay, there are scenarios where I find that a beam is not supposed to be a cantilever, but then the program is showing it to be a cantilever beam. Okay, so in that case, we select the beam, like for example, this beam here. I can click on it. You right click, mark free end of cantilever beam. Then you can choose this option, both ends supported. If it is this option, then it will cease to be a cantilever. And this means that at this point, this beam is supported. Okay, but in actual sense, we don't have a support here. So The program will try to identify for you those conditions. But where I find that it is not right, you can use that option of marking with both ends supported. Okay. Now, you see this is the staircase area around here between grade P and R. So at this point, we need to have a beam which is going to where the first flight is going to be anchored, and also where the last flight will have to be anchored. You get it? So our staircase is going to start from the beam connecting between these two supports. So you can include this. It was not part of the layout, but it is necessary. Okay, now the level where we are right now, you can identify it by looking at a story which is having a bold description. Like at this level, I'm at story 1, which is plinth beam level. So if I open first floor, I have to double click open first floor. There is nothing. Okay. Now at plinth beam level, we have columns there. We imported those columns. When you are creating columns in ProtaStructure, they are created on levels above. That's why when you go to your 3D, you see these columns projecting from the plinth beam level to the level where you have the foundation. Let's launch the 3D window. You click on views here. Click on views, then right click. Choose 3D physical model. You click on views, right click, and then choose 3D physical model. It will take you to the 3D environment. So how you're going to navigate through this 3D environment, you can right click and hold. Right click and hold to rotate. The right button of the mouse and rotate. Now, if you don't have a mouse, this is where it's going to be very hard for you. Okay? So you need to right click and then drag to rotate. You click on views, go to where you have the structure tree. Are we all at that point? Yes, I have noticed that most of you have been creating structural elements at the foundation level, story 0. Now, when you create beams in the foundation level, they are taken to be foundation beams. So if you try to copy them to other levels, you can't translate foundation beams into floor beams. The software cannot recognize it. So when you are starting your project, every element that you are going to start with to create, it should be created in story 1. Okay. Now, most of these beams are carrying walls. At the ground floor level, most of these beams, they are carrying walls. So let's look at how you can configure a wall load onto the beam. Under loading, in loading, click on partition wall loads. There are template loads that have already been defined there. Under loading tab, click on partition wall loads. Then you get a beam wall loads library. Most of these loads that are there, they are not as per. Yeah. So our walls are 200 mm thick. So this is the 200 brick wall Malaysia, 200 brick wall Singapore. It's just a description. We are interested in the contents of that particular description. So we can just choose any of these ones. It can be even this one of 300. We are going to customize it. So get this one of 300 brick wall. You can duplicate and create your own copy. Just click on it and then duplicate. You get this, which has 300 brick wall copy. Then click on it and rename it to be 200 mm thick wall. Okay, just put a description that you can trace when you're loading the beams. I'm putting 200 mm thick. After naming it, we now look at the contents. The layer name is brick. If your walls are blocks, you click here and choose either you want medium dense blocks, or bricks, or plaster. Okay. Now, this is a okay. Let's choose brick. Keep it brick, but then the layer thickness, let's have it to be 200. You need, when you look at this dialog box, on the bottom right corner, when you point there, you can minimize or expand that box. So you need to look at the units that have been used here. These are millimeters. So this has to be 200 mm. And the load value is automatically calculated. Okay. Now, this is per square meter, a kilonewton per square meter. When you choose a material here, let's say brick, you have a unit weight of that material already predefined. There are some specifications that must be known based from the manufacturer, okay? Or their standard units of measurement. Like for brick, the unit weight here is 20, but if you know that maybe the kind of bricks you're using, the unit weight is different. You can look at edit materials here. Under edit materials, that's where you can input a custom unit weight. Unit weight, it's like density. Okay, you put the density of that material, and the load will be computed automatically here. Now, if you have if this is your beam, you have computed that you have a wall spanning from this point up to this point. Okay, this is the length of 4 meters. Okay, the load that we are going to input there is going to be a uniformly distributed load. Like, you consider that this beam is going to be loaded from the start up to the end. And the unit of measurement for distributed load is what? Uniform loading, it is given by a kilonewton per meter. Okay. Now, what we have so far, when you look at the layout here, is a kilonewton per square meter. Okay. Where this load comes from, you get the thickness of the wall, which is 200. In meters, it's going to be 0.2. Multiplied by the unit weight, which is in this case 20. Okay, that's where they are getting the 4 kilonewtons per square meter. Okay, then we need this to be distributed per unit length. If this is 4 meters, then we shall definitely have this divided by 4 to get this load as 1 kilonewton per meter. Okay, so but what Plotter does, you're not going to also like going through this calculation. Just input the thickness of the walls and the unit weight of the material which you need. Okay, so if in case you need also include the plaster, you can click on add new layer. When you choose add new layer, you get another provision where you need to select the material. You can choose plaster, any material which you want to put. Okay? If the material is not defined among these ones, you need to customize your own material. But you need to make sure that you know its density. So the inch weight of plaster is 18. You put the thickness of plaster. If let's say it is 10 mm, and this value will be automatically calculated. Okay. So now, what the architect has indicated is 200 on the architectural layout. They expect that the total thickness of that wall is going to be 200. Then as you're designing, you need to factor in that in a way that you're going to reduce the thickness of the bricks here. Let's say you can put it at 190 and you have plaster one side of 10 mm to keep within the thickness which has been defined on the architecture. Okay. So if it is plaster both sides, then this you can put it at let's say 180, and then you add another layer for plaster, just like that. You get it. Okay, so let's keep it like this. So the total load here is 3.98. I'll click OK. And then we add it on the beam. We can select one beam, right click. When you're selecting the beam, don't click on, like in the center. When you click in the center, you will select the grid. And the selections will be a bit different. Okay? So select the beam at its edge, right click, and then edit wall load. You right click on the beam, then choose edit wall load among these options. Then from here, you select the kind of wall that you want. This is the 200 mm thick you have configured. So choose the load that you have configured, 200 mm thick. You define now the wall height. Click here, choose 200 mm thick, and then put the wall height. That wall height, you're going to deduct the thickness of the slab. If our height is, what is the height that we have? It is 3,000. 3,000? 3,100. You need to confirm from the section. You look at either the section or elevation. So the height is 3,000. But you see this height is taken up to the top of the next slab. That's why we deduct the slab thickness. So you will be putting here 2.8 meters, right? But then someone can say that, for me, I have some walls which end below the beam. Okay, if you find that this is your layout, if this is my layout, this beam is a drop beam, okay? But this beam is a slab beam. Slab beams, they have the same thickness as the thickness of the slab. Like, actually, we have it here in our layout, if I can finish them, right? Okay, when you look at this, this is the slab beam. Its thickness is the same as the thickness of the slab, okay? So if you deduct the thickness of the slab, you have catered for this. But then there are some beams which are dropping. If this beam is, let's say, 400, then in your cross section you have areas where you find that this is the slab and your beam is dropping like this, and a wall will come up to here, isn't it? So, but when we are designing, we look at all these scenarios and disregard this scenario, this one here. We take it that all the beams are ending at the bottom of the slab. What we are interested in is a height which is a bit bigger, because a bigger height will give us a bigger load of the walls. You never know what may be this, the function of that room may change. Okay, clients are very funny. So you design for a worst case. So we just take off 200. Okay, we had edited the wall load. So this height here, let's have it to be 2.8. Then I'll click OK. So among your beams, there should be that beam which shows that there is a difference. Okay. If you go to your 3D, you will see that wall when it is loaded. That beam when it is loaded with this wall. Okay. It is a height. So in the 3D, you get this kind of. There are some walls which have openings, windows, doors. In case you want to put those openings in this lot, like you deduct that part which has a window. So in your plan, or even still in 3D, you can just select that beam and still edit wall load. It will take you back to this position where we have edit openings. Okay. So edit openings, you can add the openings from here. You click on add. Down here, you click on add. If this is a window of, let's say, 1.2 by 1.2, you put the width here as 1.2, 1,200. Where there is a millimeter, also put the input in millimeter. So 2.2 by 2.2, that is W and H, height and width of the window. Then we have X and Y. X, that is the reference position along the length of the wall. If it is in the center, you give the offset. Okay. Now here, the dimension is 40, 50. If I want it in the center, then this distance should be half of, okay, this distance minus the 2.2 divided by 2. You get it? We've understood that. Eh? So I'm just putting it at any position. If it is a door, you define the height, and then this, for this case, this is the sill height for a window. If it is a door, this should be 0. Then you have it positioned like this. Okay. If it is a window, you can maintain a sill height as per the architectural drawing. Okay, so here I'm just playing around with the figures. If I click OK, then OK, in your 3D, you have that opening added. So the load that will have been computed, it will be minus this part. If it is your house that you are designing, you can do it that way. Okay? But then if it is for another client, don't include those openings because you don't know. See, the moment you include this opening, you're telling us that the weight of this beam doesn't include this opening, but you're going to fit a window there, which window also has a weight. Those are maybe if it is a steel casement window, that load must be catered for. You may get less reinforcements, but then how are you going to look at the steel for this window? Okay. So that's why in normal practice, to be on a safer side as the structural engineer, don't include those openings. Okay. So let's right click again, edit wall load and edit openings, delete that opening there. Choose it and then delete, then okay. Okay. Now we have the load on only one beam. At that point, we have the load on only one beam. We need this load to also other beams. You select the beam which has the wall load, right click, choose copy wall load. Copy wall load. After copying it, we need now to put them on specific beams which carry walls. Where there is no beam, where there is no wall, don't put a wall load there. Okay. So like you can identify this beam, you hold control, select another beam, hold control, select another beam. As you keep on holding control, you paste it on the beams which carry walls only. As you hold control. First select a few, eh? First select a few, don't select all. After you've selected them, right click on any that you have selected and then paste copied beam loads. Remember, you have already copied. So here you're pasting. You paste copied beam loads, proceed. Now, what I want us to do is you may need to select all the beams at once, okay? And then just identify those ones where you need to remove the whole load. They may not be many. It is easier that way, okay? So you go to modeling. In the modeling tab, look out for selection filter. You see it at the top right-hand corner. Selection filter. Select deselect all and then choose only beam. Okay. We click on deselect down here, and then you mark only beam. You're marking only beam to show that when you're making, like when you're selecting the entire layout, only beams must be identified. So we can make a window selection. Okay, I can repeat, sorry. We select the beams. Okay, are we all at story 1? Confirm that you're at story 1. Now at story 1, when you double click, when you expand it, you see columns, shear walls, beams. Okay. When you expand beams, you see 1B1, 1B2. Okay. Any beam that you select from this area, it will have to reflect that it has been selected in this other window. Okay. Now I need us to select the very first beam, 1B1. Okay. Click on 1B1. Then scroll down. Use the mouse wheel, scroll down. Hold shift and click on the last one that you have. Okay. All your beams must be selected now. Okay. All the beams will be selected. After selecting them, you right click on any which has been selected. Let's say this. Then you still paste copied beam loads. Have we selected them? Right click on one which has been selected, any of them, right click. And then choose paste copied beam loads. We are pasting the other load that we copied initially. So all your beams will have wall loads. Now, I did that specifically to show you how you can remove some loads that have been added. You don't just select the beam and press delete button. Okay. Like these beams here, we don't have a partition here. So you select that beam, the slab beam. Okay. You select the slab beam, click on it, right click, you choose delete wall load. Delete wall load and click yes. You do that for all the beams that you think should not carry walls. Delete wall load. Delete wall load. This is a staircase area, right? Here. Does this beam have a wall? Yes. Doesn't have a wall. So also you delete it. I forgot to create this other beam here. But here and here should be two beams. Let's take this seriously. This is mouse. Yes, look, we're using also so you get a mouse. How does layout? Now, is there anything missing at this level? Do we have any structural element missing at this level? Yes? Is there? Is there? So we are now his pattern here would modest that. If you remember what I said, we design suspended. So we don't have the basic. Then we don't start. We start putting stars from. Now, we are shifting. When there is no basement. When there is no basement. It is very fine. You see, what we are looking after in design is one is deflection, bending. So you are already on ground floor level. You are putting hardcore, you are putting, you don't expect bending at that level. You get it? Yeah. So we don't design that level completely. we just put oversight concrete. Yeah. But then if there is parking to be used, maybe this level there is parking, but below, okay, there is I don't know how I can. If this level is parking, but below it, the place can still be accessed. It's now a basement already. You get it? Yeah. So if it is not suspended, if you have a slab on grade, it's called a slab on grade. You don't model slabs there. Yeah. Okay, now when you're shifting from one level to the other, you need to make it as a rule that you need to make a review. Relabel all your members because there are some members which you have deleted. Okay, so now the numbering is not consistent. Okay, so under review, relabel members. Review tab, relabel members. Then click yes. Review relabel members. You mark columns, everything, even if you have that element, if you don't have it. When you're making a review, check all of the structural elements. Okay, so, and then click OK. After that, we can now proceed to first floor. Now, you see why I'm emphasizing relabeling all the members. You can only encounter this problem when you are practicing. So sometimes you can copy an element and just refuses. They tell you that that element is already available on other levels. Okay. So you need to make sure that all your members have been relabeled. Now, after relabeling the members, let's proceed to first floor. We are going to make a window selection. When you're selecting in ProtaStructure, you have bottom right, top left. Okay. Hold down the mouse, the left button of the mouse and drag. It will come with a green background. Okay. You can also select from top left, bottom right. Comes with a blue background. What is the difference between the two kinds of selection? If I use a blue background like this, if my focus is to select these grid lines, nothing will be selected. However much my background is covering those grids because it's not covering full grids, okay? The element is not fully captured. If I release, it will not capture those grids. But then the moment I use a green background and I select like this, I just need to touch those elements just slightly and the grids will be selected. So make sure that when you're selecting, you use the right selection that you want to use, okay? Now, when do we use a blue background? When do we use a green background? We can use them all at all times, okay? Now, the question of when, like, it will come in after you have selected. The whole point is making a selection. Eh? So if you use a blue background and what you want is not selected, then you switch to use a green background. You try to explore most of the options. Now, in this kind of selection, we would select like this. That's okay, we can select like this. But then our focus is just picking out beams and columns. You don't need grids. Those grids are created on all the levels. The moment you create those grids, you find them on first floor, second floor, even those other levels that you haven't created, the grids will be there. Okay? So if you are good at making the selections, I can use a blue background and select like this. And the grids won't be selected, but the other elements will be selected. But then for the start, it will be a bit challenging. Okay? Then we use what we call a selection filter. Modeling, we have used this before. Under modeling, click on selection filter. In the selection filter, you mark what you only need to be selected. First of all, they will come when they're all selected like this. Okay? So what you're going to do is to first deselect all. Okay? You click down here and choose deselect. After deselecting, you mark column, you mark beam. Then here you are free to either you are using a green background or blue background, whichever. Doesn't matter. Okay, you just select anyhow and cover the entire project. It will only pick out this column and beam. We are that step. Okay, we have selected all. Mark what you want to be selected and you drag around your project. Okay. After that, we now copy elements to other levels. Right click on one of the elements that have been selected and then generate members to other stories. You choose generate members to other stories. We are moving. We have the source story and the target story. Source story, it is already selected, plinth beam level. It is even inactive, you can't. Okay. So we are moving from plinth beam level to first floor. You choose first floor, the target story. And then click OK. Right? You click OK. And then in your, just if you have launched the 3D and you've taken time without shifting to the 3D window, first save your work before you shift to the 3D mode because the program is going to freeze. It might freeze. Okay. But if you have been using both windows, it is okay. So in the 3D, you have first floor created. Now, when you are designing, you look at a process which will not take you a lot of time, okay? If you realize here, for these beams here, we could have copied the beams before loading those beams, but then it would give us again more work to load the first floor beams, load the ground beams, you get it? So before you finish a layout, make sure that at least you have exhausted whatever you need to do at that level. You need to move systematically. Are we all at this step? I'll switch to plan. Control S is for saving. You may need to keep on pressing Control S. So on plan, confirm that you want story 2, because now we want to create slabs. On story 2, we have slabs there. I'll need to look at this. Okay. Now, in the beginning, we agreed that where we have the wet areas, we are putting solid slabs. So here we have a washroom, but then the washroom, the partition that we have spans from this point up this point, but our washroom ends here. Okay, it ends around here. If you look at the layout, this washroom ends around here. Therefore, if you are to have a transition between the solid slab and the ribbed slab, you need to have a boundary element. Okay, so let us create a beam there from this point up this point. You can double click on one of the beams there to launch the properties, and then draw it there. Okay. In this area here, we have a washroom there. So let's create a beam to separate ribbed from so. Is that okay? Let's have a beam separating. You see, this is what I'm talking about. Here you have a washroom, and this is a passage. So for a passage, you don't need to have a solid slab there. It can be a ribbed slab. So, but then for us to have that transition between the two types of slabs, we need a beam. Okay. So you create that beam on grid 7 between D and F. Don't know. Actually, it's also around here. Also here. From this point up this point. Still on grid 7 from L to M. There any other point? Yes. also here, also at this point. So when you look at grid 7, there are these 3 beams that we need to introduce. These 3 beams. They have walls. So you can also look at copying the wall load and then paste on those 2 beams. Paste copied beam loads here, paste the post here, and also here. Yes. We're adding this beam to have a transition between a hollow slab and a solid slab. Because when you are, what's going to happen on site? I'm assuming that if these are my panels, the beam is here, right? This part is solid, this part is hollow. Now, when you have if these are the ribs, these are your max spans. Okay. Now, the reinforcements, they're going to come between the ribs, like from this point, they'll end there. You get it? They'll end in this beam. Also, this is going to end in this beam. Then also for the solid slab, it's going to be separate. Okay? That's why this beam is very, very key. We added it there. After that, let us create the slabs. When you're creating slabs, functionality should be at the forefront. So this is a washroom. We are going to use solid slabs. You click on slab. Click on slab. Yes. Let's click on slab. By the way, confirm that you're on first floor. Avoid. Okay, at first floor, we're at first floor. So at first floor, you click on slab, modeling slab. Now, according to the architecture, you need to look at the section for details. The section doesn't have the slab thickness, but the minimum thickness of a solid slab should be 125 millimeters. 125 millimeters. But then that means that that kind of slab is in a very small portion. So when you're designing, you look at the loads that are going to be carried by that building. But you say we have already deducted a 0.2 on the wall loads, that the slab thickness. So we cannot again go back. So let's use a thickness of 200 mm. Okay, but you can also have slabs of 150 mm. It depends. After you have modeled it, then through those checks, it will either show you that maybe the slab is failing in flexion. That's when you can go into adjusting the effective depth of that slab. Okay. So On first floor, let's have the H to be 200. Then concrete cover, let's keep it as 25. And the loads, when you're creating the slabs, don't forget to add loading. So the dead loads, we have dead loads. Do we all know dead loads? Yes. So the dead loads we are going to consider here, it's particularly self-weight, the floor finishes. So you can look at tiles, you can look at screed, okay? But then once you have gone through some calculations, you find that most of the finishes, they will not exceed the 1.5 kilotons per square meter, because here you're dealing with area, okay? So here you can put 1.5 or below, but not a value which is less than 1. If you're not sure of this value, then you need to configure your floor finishes and pick it from this. We have enter value here. If you choose room, here room gives you a value of 2.375, but where did that 2.375 come from? Okay. So initially, this program has configured that value based on the layers of the finishes that have been configured. So when you look at loading and then under slab additional loads, under slab additional loads, you have load names, room, terrace, balcony, lowered slab. Okay, so particularly the room, the one we took, has a layer, cement grout, ceiling grout, finishing concrete, mosaic tiles. Okay, so that's why you are having a value of 2.375. But then this value, it depends on the thicknesses that have been given here. Okay, so finishing concrete, okay, it depends. These descriptions are going to be added on the building section. Okay, so it will be upon you to judge what layers do you want to work with. Okay, so like for example, if I have right now I'm on the first floor slab, I may not need finishing concrete. Okay, if I leave finishing concrete, then in this case maybe it's going to be the screed. Then I'm going to remove cement grout. If I remove cement grout, I leave out ceiling grout and maybe mosaic tiles. Okay, so how to remove any that you want? Just click on X. Select what you need and click on X. Okay, so but whichever thickness that you add here, let's say this is the thickness of 25 mm finishing concrete. Mosaic tiles 15 mm is too much. You can have it as maybe 8 to 10 mm. Okay, if it is 8 mm and a ceiling grout, now here ceiling grout you can consider, let's say 15 mm, and also this total load is going to be affected by the unit weight for those particular layers. You may find that based on the type of cement that you're going to use, this unit weight of ceiling grout is going to be different. Okay, so you can go into edit materials and look out for ceiling grout and edit that unit weight, just like we did for walls. So basically this value will not exceed 1.5 mm. So if I keep it like that, and I click OK. When I come to modeling, I'm trying to make a slab where I have the loads and I pick room, it will come with that value of 1.0 something. You get it? And then if you're not so keen at those calculations for flow finishes, use enter value here and put a value that you need. So let's have 1.5. And then the impose loading. So we are creating that slab for the washroom. You can right click where you have impose load, right click and choose balcony, toilet areas. Okay. So here we need it to be maybe toilet areas. I'll choose toilet areas, which is a value of 2. Now, when you're starting your project, there's a code that you picked, Eurocode UK. So those values are picked from that code. If you choose a code, let's say British standards, you may find that for toilet areas, it's different. Okay. Then, okay, under general, we gave this to be 200. Now, loads, still under loads, we have the roof load, does not apply here. Snow load, rain load, keep them blank. And then this other last option of slab does not contribute to flow diaphragm. You can only mark this if you have inclined membranes. Like if you decide to create slabs which are at an angle, then you can mark that slab to be like it shouldn't contribute to the flow diaphragm. Flow diaphragm will mean that in the event of a lateral loading, let's say wind or earthquake, all those joints are going to like receive the same impact. If it is displacement, like at this joint, and the lateral load is from this direction, this joint and this joint will receive the same impact. If it's a displacement of, let's say, 6 mm, this will also have 6 mm. Okay, so but that does not apply for inclined members. So that's why we have to mark it. So for this our case, we need it to contribute to the flow diaphragm. Now, when you're placing your slabs, come back to general. We have this important step of selecting the panel type. If I'm putting this slab at this point here, the panel type would be one short edge discontinuous. Now consider all the lines that I have drawn here as beams. In design, this is taken to be an interior panel. This one, it's interior panel. Because once you cross this beam, there's a slab here, there's a slab here, there's a slab here. So it is within, so it is an interior panel. But then, when you look at this panel here, this one, here I have a slab, I have a slab, I have a slab, but then on the opposite side, I don't have a slab continuing. So we take this to be, the panel type is going to be, if this is the long edge, it's going to be one long edge, discontinuous. It's not continuing. this other side. This is going to be one short edge discontinuous. Okay? But then this one, two edges discontinuous. You don't have to cram this. Okay? The software has it here. You just need to know the arrangement of your flow. Once I choose the first one, this is an interior panel. Once I choose the next one, one long edge is discontinuous. Shows you that on the other sides, they are slabs. Eh? So here one short edge. But still, Plot simplified it for us. We may not focus so much on selecting that panel type. At the end, when you have created all your slabs, there's an automatic feature which you can launch, and then it categorizes them for you. But it is important to know what they mean. Now, let's ignore that and look at the insertion. Yes. Yes. Now, this one, you take it as one short edge discontinuous because the bigger part of the long edge is continuous. You get it? Yeah. So, yeah, I'm leaving. If you were keen, one was the one which was there, default. So I'm not, if I keep on choosing a type here, we are going to waste a lot of time choosing the type when we are modeling. Like I've said, there's an automatic way of doing it at the end. Okay. So let's keep it the way it is, default. And then the insertion, we have a beam region. That is a region between beams. Eh? If where you're putting it all is enclosed with beams, you can choose beam region. So let's have beam region and click here, add that slab. Also click here, we have a washroom, and also at this point we have a washroom. Okay. Do we have that? Now, we have some balconies, okay, which are cantilever slabs. Let's go back here. We have a balcony at this point. For balconies, it is mandatory. You need to choose a panel type to be a cantilever, type 12. Choose type 12, and then go back to loads. We have changed now the function. It's no longer wash. Right click and choose balcony, where we have the imposed load. Okay. Where we have the imposed load, right click and choose balconies. So here it has balconies, guest houses, hotels and motels. You choose what you think it is. For our worst case, you get it. Okay, usually I go with a 4 because in the actual manual, the code has it between 1.5 to 4. doesn't categorize balconies for motels, balconies for this. Get it? So go with the 4. Okay. Now, under cantilever, we need to define this L cant distance. The L cant distance, that is the distance from the beam outwards. Like, you want to put it here from this point up to this point. What is the distance? I've not measured. I can first leave it like that. I'm going to just have an estimation if it is, let's say 1.5. Okay. I'm going to have 1,500. After I have created it, I can measure and update what I've added. Under cantilever, let's look at L cant. You put a distance of 1.5, 1,500 mm. Then there is this parapet load. If you have rails at the end of the balcony, you need to put this load. This parapet load, you can configure the unit weight of steel. What is the density of steel? If we are to have steel rails, so the density of steel, the unit weight of steel is 7,850. But this is kilogram per cubic meter. Okay. So you need to convert it into Newton and then have it in kilonewton per cubic meter. We need this measurement in kilonewton per cubic meter. How do you convert from mass to weight? Because this is mass multiplied by the yeah. So that makes it so mg. This is multiplied by 9.81. You get it in a Newton. Okay. So this is going to be a Newton. You convert from a Newton into kilonewton, divided by 1,000. So basically, you can it will be around 78. Okay, 78.5 kilonewton per cubic meter. So that's the density of steel. You get this unit weight of steel, multiply it by the thickness of steel which you want. Okay, so that is anyway, that is going too far. Let's make an approximation of this parapet load. Let's have it to be 1 kilonewton per, because a kilonewton is a huge force. It can be one like this, but remember, it is just in a localized area. You get it? Okay. So let's have it as 1 kilonewton. put a value, and then in general, when you're drawing cantilever slabs, go here and choose peak points. You choose peak points. Because you need like to draw from one point, which should be an axis intersection, like from this point to this point. And then the software will define for you how far you need to go based on the L count distance that you entered. We had it as 1.5, I will click, then have that slab created. Okay. So you select from one point, let's say here, we have it at grade C to E, okay? C to E. Then, I don't know that. Let me, okay, create for this other side, T to V, axis intersection to axis intersection. After you've chosen the other point, now you need to choose which side is the cantilever, is this other side. You click and place it. Sorry, I'm encroaching on your time because we started a bit late. I'm going to end at exactly 5:30. Yes, this arrow just represents that it's a uniform distributed law along from the start to the end. Why don't we start from the column? What does the architecture say? It starts right from here. Okay. So when they're arranging max spans on site, these max spans will not come up to this point. They will stop at around here such that the reinforcements that are going to be for this other slab, they will go at a distance. The distance to anchor into that beam. So I've noticed that our L count is supposed to be 1.3, 1.4. Is it? Double click on that slab that you have drawn and modify it to 1.4 and update. Shall it's 1.3. Modify it to 1.3, then update. Double click on it, takes you to properties, cantilever, put 1.3, and update. So we can now create cantilever slabs. Can create solid slabs. Now, let's look at how to create ribbed slabs. So there are some slabs that I've not created. You're going to create them, like this other one, this other one, these ones which are this other side. Okay, these ones you will create them. Now, creating ribbed slabs, you click on ribbed slab. Ribbed slab. Okay, we are trying to create this kind of slab, max span slab. So what are the ribs? The ribs are these gaps which are left between the max span, the lines of max span. So we call them rib beams because that's where you put the reinforcements. Okay. Then what are the attributes of that rib? So in general, we have BW. BW, that is the width of the rib. So when you create a cross section through that slab, it will be like you have something like this, or something like that. That isn't it? Actually, it's not. It will not be even like that. It will be like this. This is the beam, rib beam. The max span there. Then the rib beam, the max span there. So I've just taken a section through one point. Say, okay. Now this is where we have the hollow slab. Okay. Now we have said that now those ribs, this is where you're going to have the reinforcements. Either two at the bottom, around here. I mean, these reinforcements which are going to go into, like if I can zoom here, you have bars running within here and here, here and here. Okay. So that is what I've indicated in this. Now, we have some parameters to define. One is the overall depth of the slab. It is going to be taken from this point, up to the top. So this one, this is the edge. This is H. Our H has been what? What depth of the slab have we been using? 200. So I'll have 200 here. Okay. Then on top of this max span, there's going to be a layer of concrete. So that layer of concrete, you may find that they can even put BRC. I'll just represent it with a line. If this is a line for BRC at the top. Now, that topping of concrete, we are going to give it a thickness of 50. So this leaves this, how much? 150. Okay. So in your input, this is going to be the BW. Okay? The width of the rib. That width of the rib is taken to be 150 mm. (150 mm). Basically there. And also this from this point up to this point. So we shall take this to be 300. By the way, how you're designing, how you put in those figures, those are the exact max spans you're going to get that have to be used inside. Yeah. So now, based on our input, we shall have this BW. I've said it is what? 150. Overall H is what? 200. And then this is the topping of concrete, 50. And S block, that is 300. Okay. Now, this is a hollow slab. Okay. This is a hollow slab, but it's a waffle slab. So if you are designing a waffle slab, you'll use grillage. From this option here, come and choose grillage. So that's not the kind of slab we are designing. We're using max span, so just keep it standard. The other thing here is now insertion. Okay, we can keep insertion default. Let's look at loads. Let's give a dead load of 1.5 steel floor finishes and impose loading of 2. You can right click here and choose whatever function that you want. It is the residential building. So you can use 1.5, but better use 2. Okay. I'm going to show you why you need to use 2, but also 1.5 is okay. The range is from 1.5. Okay, so after that, now come back to general and we insert the slab. I'll just need to change this from peak points, take it back to beam region. It should be beam region, and then you click region of beams to receive that slab. I'll choose here. Okay. Click to place here. I'll place here. I'll first place those ones. Okay, even this. The others you can place as long as you leave this part of the staircase. Like you don't put a slab there. Now, for the few that I have added, we need to look at the span direction of the ribs. Ribs must span the shortest distance. If I talk at spanning, they should be parallel to the shortest distance. Now, here, it is the reverse. So when you are, if I double click on it and go back to its properties, we had this part of insertion. So from here, you can change the rib angle to 90 and update. Okay. So in case you are drawing it and maybe you want to change the rib direction, the insertion, change the angle to 90. So likewise here, now, actually, this is very good. When you look at this area here, if I have ribs spanning like this, that means that this beam is only carrying weight of the slab, the cantilever. It's not receiving a load from the ribs. So now what is happening here? You have loaded the slab beam with the ribs. Now, a slab beam is going to give you a lot of reinforcements. You may find that even the depth that you added there will be insufficient, demanding you to make a drop beam at this point. Okay? How we can do away from that? Make sure how I created the ribs. I went to rib this slab. I went to rib this slab and then you look at the parameters which your colleagues have. But basically, you go to rib this slab, feed in what you need under general loads, and then you change the insertion point to beam region, and then click the region where you want the ribs to be. Okay. So I was saying, if you don't need a lot of reinforcements in this concealed beam, you need to change the rib direction here now. See, there's many factors which you need to consider. But ideally, if I had this to be a drop beam, it was very okay for me to have these ribs running like this. Because even for this other panel, it's just going to be continuous, such that the bars are curtailed from this point, and then they'll run up to this other point. But then this means that here, I'm just going to have something like that. Instead of having the ribs spanning the way they should, like in first principles, how they should. Because I've added a slab beam there, I'm constrained to that. You get it? Yes. Okay, I'm saying this area, we are supposed to have something that kind. Because I'm having the shortest span as this. Therefore, my ribs are supposed to span like this. Okay? But then, this means that I'm overloading that slab beam. You're going to design it and keeps saying it. And once the slab beam is failing, the only alteration that you have to do is just changing the depth. Changing the depth of a slab beam, you rather design a drop beam. But if you are constrained to that, then you change the orientation. You get it? That's why when you work on some sites, you find that the ribs are spanning like they are not span. Okay, they are spanning in a wrong direction, but most of those they are done intentionally from conceptual instead. So when you go on some sites, you find this kind of thing. First, inquire from the design team what happened. Don't just criticize, it's supposed to be like this. You get it? So here, I'll put it like this. Is that okay? Then this part here, you remember our staircase ends here. But then this part, we don't have a staircase. But like to make construction easy for that staircase, remember, the bars are going to run from this end down from this other side. You're going to have this to be a solid slab still. Given the fact that it's even having the highest impulse loading of 4. So you'd expect that at a certain time, you'll encounter scenarios where you have many people coming running on that slab. There are a lot of vibration. You get it. So that's why you can give it to be solid slab. The other reason would be in construction. When they are detailing those bars, you look out for a simplest way of how the bars are going to be curtailed from this end into the inclined portion. So I'll leave you to create the rest of the slabs. And I'll end that report. Yes. So I'm ending at that step. Are we all okay? Okay. Let's catch up tomorrow, but I would expect you to come when you have done all the slabs, such that.